today I'm going to talk about the review of fundamental semiconductor physics. So let's start. First, I will talk about the MOSFET. Quickly. So a MOSFET has 4 input gates: that source, drain, and gate, and substrate. So there are 4 input gates in MOSFET, and then MOSFET has the current will flow like this graph. In ideal case, the current will flow like this way, but in the real world, the current flow like this graph. So there are of current in here, and then before the threshold voltage, the current will flow linearly, and then after the threshold voltage, the current will flow like this, like saturation. So we should know about the characteristic of MOSFET, and then also we should know about the characteristic of current flow. So we should remove the off current a lot. So yes, let's talk about later. So first, let's talk about the Maxwell equation. This is the basic equation of electromagnetics. So we should know those 4 equations because this is the basic theory of electromagnetics. And so in conclusion, those 4 equations means electric field and magnetic field influence together, and then the current will be made by those electric field and magnetic field. So we should know about this equation well. And then let's talk about the quantum. The electron or something else has a special characteristic like energy quantization and quantum tunneling. So every electron has those 2 things. So every energy state is divided by like this, and then energy quantization always happened. So every carrier, every electrons has those characteristics, and this is the quantum tunnel. This is also a very important concept of our physics. Electron moves like this wave, and when it meets a wall like this, if the electron has enough power, it can tunneling like this way. So actually we think we cannot move other side, that if the wall is in here, but in the quantum mechanics there are so little word, very small word. So if the carrier or electron has enough power, it can push and then jump to other side. So we call it quantum tunneling. And this is the basic energy band of carriers. There are 3 types of the 3 types. So valence band is the fully occupied band. So they are electrons occupied a lot. And then after valence band, there are forbidden band. In this reason, no electrons in here. And then after conduction band, there is fully emptied band. So forbidden band, we cannot stay in here because actually I said there are basic concept of energy quantization. So in here there are no quantized trap in here. So actually every carriers cannot stay in here, but after we make a semiconductor, we can make a trap in here. So yes, we can talk about later. And so the basic concept is valence band has fully occupied by carriers, and conduction band is fully emptied by carriers. So we can draw an energy band graph like this. This is a direct band gap and indirect band gap. So in this case, the conduction band and valence band is aligned in the line. So this is a direct case, and in this case, a carrier can move very easily because that carrier will not lose its energy. So there are no lose energy in this case. So it is very ideal case and very useful for our semiconductor work. So however, the indirect case, this is the conduction band and this is the valence band. So this is not aligned in the line. So the carrier should move to right side and also move to upside again. So this case, carriers use more energy than direct case, and it means carrier lose its energy a lot. So this is a little bit not useful than direct. And this is the three types of solid state. First, crystalline. It is very good state, and this is the most ideal state of solid. And polycrystalline is group. So every group, so there are reason of continuous state. So yes, this is also used a lot. And amorphous has no rule, so it made by very randomly. So it looks like this. So there are three types of solid state. And then let's talk about the doping. We put some dose in the semiconductor, and then we can change the characteristic of semiconductor. So first, if we donor, we can make the semiconductor to n-type. So this is the change it Fermi level. So this Fermi level moves up to the intrinsic Fermi level. So this will work like n-type semiconductor. And then if we put acceptor to the semiconductor, the Fermi level will move to downside. So the Fermi level is near to valence band, and this is the p-type semiconductor. So if we put some dose to semiconductor and change those characteristics, and then we use it to our purpose. So yes, and then let's talk about the energy band gap. Energy band gap, we make two types of semiconductor, and then we connect it like PN diode. After we make a PN diode, we put some voltage in here. So first we put some forward bias in the PN diode. The depletion region will be more bigger than before, and then the built-in voltage and energy gap between these two will be lower than before. However, so carriers move a lot than before. So this is the characteristic of forward bias. And after we put some reverse bias in the PN diode, the energy band gap changed a lot, like this way, and depletion region will be smaller than before. So the built-in potential, like the energy band gap in between two regions, will be higher than before, and this means the carrier cannot move easily than before. So reverse bias makes carriers more hard to move than before. And then let's talk about the MOSFET. MOSFET, if we put some voltage to MOSFET, the cap will be changed like this. This cap of oxide will be changed like this, and if we put some voltage to substrate and gate, the carriers will accumulate in here. So the capacitor looks like this, but after the depletion region, the cap will be lower and lower. Then the carrier gathered a lot. The intrinsic characteristic can be changed because the opposite carrier gathered a lot at the wall at this region. So it changes the MOSFET intrinsic characteristics. So after the weak inversion happened, the carrier capacitance will go higher than before, and then the more and more carrier gathered and they changed the characteristic. The capacitor, eventually the characteristic of capacitor changed opposite, like P-type to N-type. So this means the inversion. So after inversion, the capacitance is same to before accumulation state. So this is the basic concept of MOSFET. So we put some those in here. So on the P substrate, we put some N-type material N-type dose to make this resin N-type, and then we put some SiO2 on here, and then we put some N-type polysilicon to use gate. So this is the basic concept of MOSFET. After we use MOSFET to memory, we use a lot the MOSFET, and it is very useful material. So SRAM and DRAM is the most famous memory in nowadays. SRAM has 6 transistors and at one cell, so this is very it works fast and yes, very calculated. However, it occupy very big space, so it is not good for small device. So we also make a DRAM to. This is the one transistor on one cell. So yes, this is very smaller than SRAM, and it works a little bit slower than SRAM, but it is also very useful memory for our life. So we make these 2 types flash memory a lot. So today we talk about a review of fundamental semiconductor physics. So thank you for watching my video. Bye.